Hey everyone, and welcome. So, you're an engineering student and you're looking at this massive, booming semiconductor industry and thinking, how do I get in? Especially if you're not from an electronics background. Well, you are in exactly the right place. Today, we're going to build a really practical guide for you to forge a career in chip design. All right, let's jump right in. First things first, let's just zoom out and look at the big picture. We are, and I mean this literally, in the middle of a global semiconductor gold rush. Seriously. Everything from AI and cloud computing to the cars we drive, it all runs on chips. And that means the demand for people who can design them is just, well, it's exploding. And to put a number on that opportunity, especially if you're in India, get a load of this: $110 billion. That's what the India Semiconductor Mission says the domestic market is going to be worth by 2030. That's not just growth, that's a colossal wave of opportunity. Which, of course, brings it all back to the most important question. When you see a number that huge, how do you, as a student, actually get a piece of that action? How do you find your way in? Because let's be super clear here. We're not just talking about another tech trend. We're talking about the absolute backbone of our modern world. Your phone, your car, the hospitals, the AI, it all runs on these tiny pieces of silicon. That's why governments are now talking about chip supply as a matter of national security. This stuff is fundamental. So let's talk about what's probably the biggest hurdle for so many of you. If you're not in an electronics and communication engineering or ECE program, trying to get into VLSI or chip design can really feel like you're an outsider looking in, right? It's a common feeling. And this quote, this is it. This is the #1 question that gets asked. I'm in computer science, or I'm studying mechanical engineering. Is it even possible for me to switch into VLSI? It's the big doubt that holds a lot of talented people back. So let's just put this to bed right here, right now. The answer is a huge, unambiguous yes. Absolutely. The door is not closed to you, not even a little bit. But, and you knew there was a but coming, it's a big one. It doesn't just happen because you want it to. Making that switch successfully, it really requires a plan. You've got to understand the industry, you need a disciplined, structured way to learn, and you have to be truly committed to filling in those knowledge gaps and building projects that prove you can do the work. Okay, so that's the key, right? Understanding and then actually bridging that knowledge gap. So let's break down what that really truly means. Look, if you're an ECE student, all of these fundamentals are just baked right into your 4-year curriculum. You're learning digital logic, semiconductor physics, all that stuff from day one. If you're in CS or mechanical, your curriculum is obviously focused on other equally important things. It just means you have to intentionally, piece by piece, build this foundation for yourself. And what does that foundation look like? It's not some fuzzy concept. It's a real, concrete checklist. You have to start with the absolute basics: digital systems, how binary works. Then you build on that with Boolean algebra and logic gates. That's the language of hardware. From there, you get into how circuits can actually perform steps and remember things using sequential circuits, flip-flops, and state machines. These right here, these are the non-negotiable Legos of every single chip ever made. Now, once you have those concepts down, you're ready for the next big step, and this one requires a total mindset shift. You're going to learn a hardware description language, or HDL, something like Verilog. And listen, this is so important. You are not writing software. You're not just writing lines of code that execute one after another. You are describing a physical piece of hardware. You have to think about timing, about signals flowing, about lots of things happening all at the same time in parallel. And here's the best part. You don't need access to some $1 million lab to do this. There are incredible free web-based tools like EDA Playground. You can literally open your browser right now and start writing, simulating, and debugging real Verilog code. It's an amazing way to make all this theory feel real. So, you've built the foundation. Now what? Well, now you get to choose your path. And this is the cool part, because this is where your unique background, the thing you thought was a disadvantage, actually becomes your biggest strength. Just think about it for a second. If you're coming from computer science, you're a master of complex logic, structured code, and most importantly, debugging. That is an absolute superpower in the world of chip design. And if you're a mechanical grad, you bring amazing analytical skills, a strong math background, and this incredible intuitive grasp of spatial reasoning. That is just as valuable. So where do these superpowers fit? Well, for a CS grad, verification is a perfect home. You're essentially a hardware detective. You use your amazing coding skills to write complex tests to hunt for bugs in a chip's design before it costs millions to manufacture. And for a mechanical grad, physical design is an amazing fit. This is all about the chip's physical layout. You're figuring out where the big blocks go, that's floor planning, and then connecting the millions of wires between them, that's routing. It's like a 3D puzzle on a microscopic scale, and your spatial skills give you a massive edge. And hey, don't just take my word for it. This isn't just theory. Look at this. It's from a real job description for a verification engineer at Intel. What are they asking for? Proficiency in SystemVerilog and C++, experience with debugging tools, and, yep, excellent analytical and problem-solving skills. It's a perfect match for a CS grad who has built those hardware fundamentals. Okay, we've talked about the massive opportunity, the fundamentals you need to learn, and how your background helps you specialize. Now, let's put it all together. Let's build a clear, step-by-step roadmap to get you from where you are today to that first interview. Look, this whole transition, it's a marathon, not a sprint. But you can absolutely break it down into a manageable plan, say over a year. For the first 3 months, your only job is to build that solid foundation in digital logic and Verilog. Then, for the next 3 months, you pick a specialty, verification or physical design, and you get your hands dirty with real industry tools and start building small projects. Months 7 to 9, that's all about getting interview ready. You dive into advanced topics and you do mock interviews until you're confident. And that final stretch, months 10 to 12, that's launch time. You polish your resume, you package up your projects into a portfolio, and you start applying. A year of focused work, it can absolutely change your life.
And if you take away just one thing from all this, let it be this. Success really comes down to 3 things. 1, structured learning, not just watching random tutorials. 2, a portfolio of actual projects that you can show an interviewer. And 3, a deep, real understanding of the fundamentals. There are no shortcuts here. You have to do the work.
Which really brings us to the final, most important point. The fact that you can make this switch, that's not up for debate anymore. So the real question you have to ask yourself isn't, can I do this? It's, am I willing to put in the hard, focused work to build that foundation properly, brick by brick? And if your answer to that is yes, then this incredible, world-changing industry is absolutely waiting for you. Thanks for tuning in.